We request Professor Venkat Prasad and Mr. Sutare, our speakers of this session, to start their invited talk. Sir, please.
Okay. Yeah, can you hear me? Are you able to hear me? Okay,
yes, sir.
great. Yeah, thanks a lot. Let us move forward. Let me move a bit fast because the time is limited. And then I have my very learned colleague Sujay, so he would be able to answer your questions and discussions. So. Can I start? May I start?
Yes, sir.
Please, somebody answer me. Can I start?
Yes, sir. You can start, sir.
Yeah, I'm having lots of background noise, so I don't know what is happening there. So that's why I'm a bit worried. So because I don't want to repeat. Okay, so I'm going to start now, and let me go through the talk. Okay.
Yes, sir. Please go ahead, sir.
Yeah, please stay there, and in case you want something, you should be able to answer me or tell me things. Okay. In between, I'll check whether my voice is going through or not. Okay. So the idea is that miniaturization is taking over, and we know that Internet of Things is coming in a big way. So the idea is to take the Internet of Things to space and also support Internet of Things from space. So that's the whole crux of this talk. So we know that there used to be huge, big satellites. And then in 1960s, people have actually started already sending lots of satellites. Even around 70 people landed on the moon, right? So everything was big, and it used to take lots of efforts to build them. And 90s onwards, nano satellites came into existence. So the idea is making it really small. And in the last 2 decades, the CubeSats have evolved, and even now people are already going for picosatellites, right? So the idea is that from 8,000 kg satellites to now coming out down to 3 kilo satellites. So this is the huge, and then the mini satellites, micro, around 100 to 360, 400 kgs, and now 3 kilos, right? So this is the evolution that's happening. What you could see is that it's somewhat similar. So you had the elephants, and then coming down to let us say the humans, and then what you could see is nanosatellites, where we are already telling you now, where you have um, the fishes, the ants, they work as a swarm, right? Even the birds, right? 30 kilos, for example. So they can work together and provide you services. So just like the birds, and then um, the ants. So you can also see nanosatellites taking over and making this in a big way, right? So the idea is that is it reinventing the wheel? So that's the question, right? So it's in some sense yes, but we are improvising, right? So there is a lot of things that you could do to improvise uh, the evolution of these nanosatellites. So when we talk about sensors and actuators in space, so basically each satellite is a collection of lots of sensors and actuators, and there is huge amount of research goes behind, because miniaturizing these devices is not that easy, because these actuators need to be powered, and there must be some form factor to make them good, and so you need to really have the electronics. So whether you have the big one or the small one, except the drivers, so the controllers and other things will be same of the same size, right? So there is a limit to reduce the size and power consumption, but there is also lots of things that you need to take care. So each satellite in that sense is a collection of lots of sensors and actuators. So why we need a swarm? So if you have one big satellite, so this big satellite will take at least about 6 hours to say 8 hours to go around the earth, right? So by the time it comes back to the same latitude, it would have already taken 6 hours, so minimum, right? So then what happens is that you will not be able to, let us say, watch something that's happening, or interesting thing happening there. So for example, here you could see that there is a shape which is being tracked by one or the other nanosatellites, because you have so many of them around. Because these nanosatellites will be low Earth orbit, they would be coming back to the same uh, latitude in around 1.5 hours, 90 minutes. And this will help us, because when you have more of them, so you should be able to really carry a big thing, right? So the idea is to use replace a big satellite with small nano satellites. So even pico satellites and other things have been already thought of. So what you could see is that this was one thing that people tried to deploy lots of these small, very small satellites, and unfortunately it didn't work. But they tried, which will come down fast, collecting the information that is required. So this was the launch of the big satellite by ISRO, and this was when they launched more than 100 satellites into the orbit. So these two small satellites, TU Delft worked on in collaboration. So we provided some information, some boards, and also with respect to making the um, assembling the satellite. So these are all so many of these nano satellites that were launched during that mission. Um, so the idea is to take these things and move forward, right? So to the next level. So what we perceive is there are lots of things that could be done with nanosatellites. For example, um, the for example, the ones that you have, for example, the iridium modules that you have, so that could be replaced. And then there are also IoT nodes that Swarm company is building, and Lacuna Space built some um, uh, LoRa devices. So the idea is basically to connect to the moving vehicles around, the balloons, the ships, and somebody in the remote areas, and including airplanes, because having these nanosatellites, many of them in the sky, can provide lots of different applications. There is something else that people are thinking here, is the idea of taking this to the far end. That is, many of these nanosatellites, assuming that they can go to the other side of the moon, right? Um, so you should be able to make a swarm out of this, and they can collect lots of data. I hope the video will show you the other end of the moon, I think. Um, yeah, so when it moves from the Earth to the other side, far away, so it can actually send lots of data together to the Earth, and so that they can do things together. For example, 10 kilohertz to 20 megahertz um, uh, radio, or the radio signals from deep space could be explored, so that people can do really understand the origin of the universe, what happened, when things happen. Many such things could be really realized. So the challenges for making these swans, or swarms of swarms rather. So it's miniaturization is a must, and the energy aware computing, because you have less energy, data handling capacity is going to be very less. So maybe we have to go for distributed computing, time synchronization, localization, all such things that we need to do. So miniaturization can happen not with these wires. So there must be some way of moving away from these wires. So you could see that how much wiring or the harness gets into a satellite. So the idea is to make CubeSats and even smaller satellites. So lots of miniaturization was done at Delft, not from my side, but from a university. My learned colleague Chris Verhoeven was involved a long time back. This happened, and it was launched using uh, ISRO's satellite C9, and the payload was a thin film solar cells that they wanted to test, and sun sensors, so that you know exactly whether you're facing the sun or not. And of course, they also wanted to find out whether that sensor can work over wireless, and of course the radio amateur transponders and other things. So these are the things that were tested, and it is still alive after 14 years. And that's something, of course, it's not continuously providing the data because the battery is gone. But whenever there is enough energy harvested because of the solar cells, it sends messages. So this is another one that we had built and then tested. So it worked for about 3 months, and that was the lifetime. So this has got magneto-torquers, and also it has got micro propulsion system, which uses water plus nitrogen. So that's something that you could see here. If you are able to see my mouse, that's what something that you could see here. And these were the deployable antennas. Basically, these are the measuring tapes, and it just opens up. And this is the propulsion system, and then there were also transceivers and attitude determination and control systems. So all those things were tested, and it was about 3.5 kilos. So the other thing that is being done in Delft is by another group, where I was also involved here, is that a mini rover that can walk on the moon. And it has also got a small payload, which is just 3 grams. And it's a simple nano rover. And the idea is to take it. This is how it works. And our mechanical department in the beginning, they made this simple walking satellite. And the idea is that it should be deployed on the moon, and it should be able to send the messages and also negotiate the moon terrain. Recently, Delft launched a pocket cube. It's called PQ, Delphi PQ. So it is just 15 centimeters by 5 by 5. And the attitude and determination control were demonstrated. And it was also just about just more than half a kilo. So it has got miniaturized propulsion system, and it was launched a year ago. So there can be many more subsystems. For example, this is one thing that Sujay has built, a handheld device for satellites, and SP has its positioning system that Sujay worked on, and then this is another health monitoring system that Sujay worked on. And these were the previous ones. So we have the design of the onboard computer, which we need to test. And this is basically ADCS, attitude determination control system. And there are also free wheels and sun sensors that could be done. These were done by already tested by other groups, but lots of aspects that need to be done. Important aspect is that we have a ground station here, and we collected a lot of data for INS 1A, 1B, 1C, 2D, and 2B after they were launched. And of course, with some of our partners, we have thermo vacuum center in Dutch space system setting, and then also the clean rooms where things could be done, and also the vibration tests that could be done in-house thing. So vibration is done in another company, which is a like DRDO in India. So this is thermo vacuum test that we could do. Thanks. And if you would like to communicate at some point, you could do that. I will take leave now because I need to be on the meeting. Sujay?
Yeah.
Yeah. Thanks, Sujay, for
Yeah,
stepping
no
in.
problem. Yes.
Yeah. Thank you so much. So if there are questions, Sujay will take over. Shanmugan? So I'll drop off. Thank you so much.
Thank you very much, sir.
Yeah.
Thank you very much.
Yeah. Bye.
Sujay, sir, thank you.
Yeah. Thanks. No problem. Are there any questions?
The session is open for questions. Any queries? Thank you so much, sir.
Okay. Yeah.
Thank you. Thank you, sir.
Okay. Nice. Yeah.
We request our joint minister, Dr. A. Ramesh sir, to introduce our speaker, Dr. Prakash Rao.